Have you ever faced the challenge of serializing and deserializing polymorphic trait objects in Rust? It can be quite a puzzle, right? If you're struggling with this issue, you're in the right place. Today, we're diving into how to tackle deserialization of polymorphic trait objects in Rust. I completely understand how frustrating it can be when you think you've found a solution, only to hit a wall with deserialization. You're not alone in this struggle. Many Rust developers encounter similar challenges when working with trait objects. Let's look at the specific question at hand. One user asked, how can deserialization of polymorphic trait objects be added in Rust? They mentioned trying to use Serde but ran into issues because the serialized trait can't be implemented for trait objects. Sound familiar? Let's explore this together. So what makes this issue so tricky? In Rust, when dealing with polymorphic types, you need a way to identify the type during deserialization. This often requires a type marker in the serialized data, which can complicate things. Let's break it down step by step. And stick around. At the end of this video, I'll share a valuable tip that could simplify your Rust serialization tasks significantly. To begin addressing the deserialization of polymorphic trait objects in Rust, the user should first ensure they have the erased Serde library included in their project. This library will help with the serialization of box containing trait objects. Next, the user needs to define a trait and implement the necessary serialization and deserialization functions. This will allow the user to work with box containing trait objects effectively. After setting up the trait, the user should create a type marker for deserialization. This marker will help identify the specific type of trait object being deserialized. Finally, the user must implement a function that uses the type marker to dynamically retrieve the appropriate deserialization function. This function will be responsible for converting the serialized data back into the correct box containing the trait object. Fun fact, Rust's strict type system is one of its greatest strengths, but it can also make certain tasks like this one a bit more complex. It's like trying to fit a square peg in a round hole. Sometimes you just need to find the right tool. Now, let's look at the answers provided by other users. An alternative approach suggested by another user involves creating a registration routine for your libraries. This routine would be protected by stdsync, once to ensure it runs only once. It would register an identifier into a common static mutable variable, but keep in mind that your program must call all these routines. The user also raises a concern about the consistency of typed values across recompiles with different dependencies, indicating uncertainty in its reliability. That's it for that answer. Let's take a look at another one. An alternative approach proposed by a user involves creating a library that establishes a bidirectional mapping from typed to type names. This mapping would be used for both serialization and deserialization with a type marker. They suggest implementing a function to register types not owned by your package and using a macro annotation for types declared within your package. Additionally, the user mentions that if there's a way to access a type ID in a macro, it could facilitate the mapping process at compile time instead of runtime. Here's the tip I promised. Consider using a combination of erased Serde and static maps for your deserialization needs. This approach can streamline your process and make working with polymorphic types much easier. And there you have it. With these strategies, you should be able to tackle deserialization of polymorphic trait objects in Rust. Remember, experimentation is key in programming. If you found this video helpful, please subscribe for more tips and tricks.